Hi everyone, Will from Fologram here. In this tutorial we're going to go through the different visualization and display modes in Fologram, talk a little bit about the use cases for each, how to override those if we need to, and just generally help you understand the differences between them. So I've got the model that we set up for the interaction demo a few minutes ago, and I've assigned a couple of materials to this. So if we click on any of these, this top box has got a Rhino custom material using the wood texture. These bottom boxes are using bitmap textures, also with custom material just with a color. And you can see that they're all showing up in AR on my mobile device because our default display mode in Fologram is the rendered display mode, which will display Rhino materials. We generally recommend that you just use the Rhino custom material for anything that you want to view in AR, and keep in mind that Fologram doesn't support third-party materials from plugins like V-Ray and things like that. So that's the Rhino rendered, or the Fologram rendered display mode, which is the default. If we set the display mode to shaded instead, what we'll see is not the materials, but the layer colors for each one of these objects. So I've assigned them to a couple of different layers here, and what we're seeing in AR is those layer colors. The display mode of wireframe is going to show the wireframe edges of each one of these objects, and it's going to use the layer colors for those wireframes. You'll note that for objects like spheres, it's not showing a silhouette outline of that sphere. When we talk about wireframes with Fologram, what we're really talking about are edges in the mesh that have quite acute angles. So at the top of this sphere, edges in the mesh which are unwelded. So at the top of this sphere, we're seeing a bunch of edges, and we're also seeing the seam of the sphere. If we instead want to see the silhouette, what we can do is we can turn on either occluded silhouette or rendered silhouette. So what occluded silhouette will do, it's maybe slightly tricky to make out here in the AR display, but it's going to show a outline of all objects as if it was kind of tracing against a background. And rendered silhouette is similar. It's going to show the materials of each one of these objects as well as an outline around it. If you played video games or things like that where you're selecting objects, often it'll display like an outline around the object. That's what the silhouette display mode is doing. The other options we've got here are the occluded display mode. Now, occluded, what it does is the occluded display mode hides objects which are behind an object but doesn't render the object itself. So the occluded display mode, if you set everything to occluded, you're not going to see anything. But it can be pretty useful for setting like individual objects to be occluded. So let's make our display mode shaded, for instance, and then we set our sphere to be occluded. So we can click on, I'm just going to move this in front of these objects so you can see there's a big sphere here. If we click on that object and set its display mode to be occluded, it's going to almost cut out everything behind it. So as we move that sphere around, you can see it means that nothing behind that sphere is being rendered in Fologram anymore. The main use case for this occluded display mode is to sort of fake physical objects occluding virtual objects in certain mixed reality experiences. So let's say you've got some objects which you want to appear behind a couch. If you create a digital model of that couch and place it roughly in the same space as a physical couch and make that digital model an occluded display mode, then holograms or virtual objects behind that digital couch are going to be hidden and look like they're being hidden by the physical couch. So that's what the occluded display mode is generally pretty useful for. Occluded outline, or occluded silhouette, is really, really useful for doing things like sculpture or locating of curved objects, because it gives us an outline for what that curved object should look like from any particular viewpoint. Rendered wireframe is displaying all unwelded edges as well as materials. Occluded wireframe is hiding the objects themselves but rendering unwelded edges. Both of these can be useful for certain fabrication scenarios. The most performant display mode is typically rendered display mode or wireframe display mode. Okay, so we've talked a little bit about unwelded edges in this tutorial video. What is an unwelded edge? Well, an unwelded edge, by default, when Rhino meshes NURBS objects, all of these are polysurfaces or extrusions or a NURBS sphere. By default, angles in the object, which are quite acute, they're almost like a fold in the geometry. They will be kept unwelded when the object is meshed. And so Fologram's wireframe display mode is going to then draw those unwelded edges. With our sphere here, if we wanted to make sure that sort of every single face in this sphere was being displayed in our wireframe, we could first mesh the sphere ourselves. So now we have a mesh sphere here. Notice that the edges are being drawn exactly like our NURBS sphere in AR. And then we can type unweld. And let's just keep the angle tolerance as 0 for now, or 10 for now. You can see it sort of facets out the default display of that sphere. It's no longer averaging normals across those unwelded edges. And in our wireframe display, we're now seeing all of those edges in the model. So you can use the weld and unweld command. So to reverse that, if we go weld with an angle tolerance of 10, that's actually only welded just the top there, which in AR you might notice are now no longer being drawn. Let's see if we weld it with a much higher angle tolerance, like let's say 90. That should weld everything. And now we're not seeing any edges in our model in AR. Okay, the other aspect of display in Fologram, we've talked now about displaying objects differently on our mobile device, but Fologram will also visualize aspects of our mixed reality devices within Rhino using the visualization settings down here. The default visualization settings is to draw all users which are connected to the model, so you get a little preview of their device, as well as the name of the device, which will show you in Rhino where that device is relative to where they've placed the model and what they're roughly looking at. If you interact with the model at all, so tap and drag on the screen or reach out and perform a pinch gesture with the HoloLens, those interactions are also going to appear as a preview in Rhino. If you have a HoloLens device connected or an iOS device with a depth camera connected, the meshes visualization option will display the spatial mesh that is built up by those devices over time within Rhino. It's kind of like a low resolution 3D scan of the space that you're in. And that can be really helpful for understanding exactly where a virtual object is, the Rhino model, within a user's physical environment. If you have a HoloLens 2 connected with research mode enabled, turning on the points visualization will display the point cloud of the depth camera of that device. And lastly, turning on trackables visualization will display any detected QR codes that are being tracked with the Grasshopper toolkit for tracking QR codes. They'll display as little rectangles in the viewport. Okay, so we've been through the different display modes. We've talked about per object overrides for display modes and a couple of those different use cases. Talked about assigning materials to objects and how they're displayed in rendered mode, welding and unwelding edges for display of wireframes, and the visualization settings. So up next, we'll look at sharing and uploading models.